So in this section, we'll study triangle and its properties. We'll see all the properties associated with a triangle, but we'll do a visual proof of that. So we'll not use any formula or derivations that we know till now. All that we'll do is we'll see to it and we think that, okay, this is happening and we'll believe to it. So it's completely a visual proof of everything we know about a triangle. So sum of the measures of a triangle is 180. What makes a triangle? Different types of triangles and the centers of a triangle. We'll prove everything but visually. We'll just see to it and see if what we know is happening. So let's start with the first. Sum of the measure of a triangle is 180. Now see this triangle. Put it in any position you want to. Put it anywhere and add the three angles A, B, C. Sum of the measure of a triangle A plus B plus C will always be 180. Take any situation, pause the video and take any situation, pick up this three angle, add the three angles, take this 27 plus 52 plus the next angle, that will again be 180. Okay, this is 10 plus 160 plus 10, again 180. 99 plus 60 plus 18, again that will be 180, and so on. So this proves that no matter what triangle you make, sum will always be 180. Next property, what makes a triangle? Sum of the two sides has to be greater than the third side. So I say in this case my third side be 15.5 and the other two sides are 11.7 and 10.7. So if I add the two sides, it is greater than, yes, the two sides 10.1, 7.1, 17 is greater than 15, yes, it is making a triangle. Two sides 9.7 and 6, yes, it is greater than 15.5, making a triangle. Two sides 9.6, 5.9, yes, it is greater than 15.5, making a triangle. But now slowly see, as sum of two sides become equal to the third side, which is happening right now. 9.6 and 5.9, if you add them slowly, they are becoming equal to 15.5. And when the sum of two sides becomes equal to the third side, then it is no longer a triangle, it becomes a line. That is why you say in a triangle, sum of the two sides always has to be greater than a third side for you to form a triangle. Because if that is not the case, as you can see it in the figure, visually we proved it never forms a triangle, it forms a line. Let's study various types of triangle. First I see is an acute angle triangle. As you know, what is an acute angle triangle? All the angles in a triangle are less than 90. If you can see, all the triangles that I am making right now have their angles A, B, C which are less than 90. So all these angles that are being made right now, okay, many angles that are being made in a minute, all these angles are acute angle. But when it becomes equal to 90, it is a right angle triangle. It is a right angle triangle. So what is the range of acute? 0 to 90. If it becomes more than 90, it is no longer an acute angle triangle. But if it has a range of 0 to 90 degree, all the triangles that you can see it right now, where all the angles are less than 90 degree, is an example of an acute angle triangle. So remember the range of an acute angle triangle, visually it has proved that the range is from 0 to 90. What happens if the angle becomes greater than 90? Then it becomes an obtuse angle triangle. If you can see this triangle, first of all, it's a right angle triangle because one of the angle is 90. But if I increase this right angle triangle from 90 onwards, it keeps on increasing. All this is an example. All the triangle you can see right now which are forming are example of an obtuse angle triangle. The range is from 90 to 180. So if you go from 90 till 180, all the triangles that are being formed are obtuse angle triangle. That's the range that you can understand visually about the obtuse angle triangle. From 90 it starts, where 90 is a right angle triangle and it keeps on increasing from 90. So if one of the angle is greater than 90, it's an obtuse angle triangle. We proved what we studied. Equilateral triangle, the simplest of all the triangles, all the angles are equal, which is equal to 60, and you can see all the sides 10, 10, 10. Three sides and three angles are equal, that is your equilateral triangle. If I try and play with this, if the angles change, so will be the side. So if I keep on changing the angle, it no longer remains to be an equilateral triangle. So does my sides keep on changing. But when I make it 60, 60, 60, automatically the side becomes 10, 10, 10, which means this is proving that if the three angles are equal to 60, then the three sides will be equal. And that is the property of equilateral triangle that we already know. After that, let's move on to an isosceles triangle. What do we know about the isosceles triangle? The two sides are equal and the two angles corresponding to that two sides, which are adjacent to that two sides, are equal. So let's see 48.7 and 48.7. Angle B is equal to angle C. Why? Because AB is equals to AC. Both were 13.7, right? Earlier, both were 13.7. So that is isosceles triangle. Now if I just try play with it, AB becomes equal to BC. If I do that in this case, both AB and BC, you can see here, is 13.7. So angle A becomes equal to angle C, which is nothing but 59.6. So again proved, if two sides are equal, the two angles adjacent to two sides will also be equal. If I further play with this triangle and I try and make AB becomes equal to AC. Now this is the only two sides remaining. If I make AB becomes equal to AC, both are 15.3, yes. So angle B becomes equal to angle C, which is 63.4 degree. And that's how simple it is for me to visually prove that in an isosceles triangle, two sides and the two adjacent angles are always equal. And the last of the triangles which we see here is a triangle which comes between acute and obtuse, right angle triangle. One of the angle here is 90 degree and the side opposite to 90 degree, we know that it's an hypotenuse, that is the highest side. We know it's given here is 13.5. Side opposite to 45.5, the next highest is 9.6, correct? It will be the second highest, and the least 44.5 is 9.5. So we know the property of triangle. We also know we can apply Pythagoras theorem to this. X square is equals to a square plus b square. Check it here. If I do 13.5 square, that will be equal to 9.5 square plus 9.6 square. Okay, now let's just play with this triangle and see if this is actually happening in all the case where I make the angle to be as 90 degrees. So let's see a visual proof of this. Now I changed this right angle triangle. All the angles are changed. Now let me again make this as a right angle triangle. So after changing this, when all the sides were changing, because I was changing the triangle, again I make it 90. Then you have 13.7, 9.8, 9.6. Do this Pythagoras theorem applied here. 13.7 square should be equal to 9.8 square plus 9.6 square, which means we visually prove the property of right angle triangle, that will always come out to be true. Now let's go ahead to find out the centers of triangle. So we know there are various centers: centroid, intersection of median, where median bisects the opposite side; circumcenter, intersection of perpendicular bisectors; incenter, intersection of angle bisector; and orthocenter, intersection of pure perpendiculars. So first I start by drawing the perpendicular bisectors on the three sides of the triangle that you can see. And I see the intersection point and I draw a circle out of it. Now can you tell me which is this circle? This is a circumcircle because I used perpendicular bisector. The point of intersection of perpendicular bisector that I get is called as a circumcenter. So D is a circumcenter of the triangle ABC, where three that you can see on the sides are perpendicular bisector. They are perpendicular as well as bisecting the side. So I draw it in red right now. This 3 red represents my 3 perpendicular bisectors, which are perpendicular to the 3 sides of the triangle and bisecting them. So I know D is my centroid. With that I draw a circumcenter and a circumcircle. Now let's draw this blue. What is this blue? Can you guess? This is nothing but an angle bisector. It is bisecting the angle A, B and C. So what is the intersection point of angle bisector called as? It is called as an incenter. So I get E, which is an incenter of triangle ABC. Okay, we can very well see that it's an incenter. With the incenter, we get something called as a incircle. So circumcenter gives me circumcircle, circumscribing the circle. Incenter gives me incircle, which is inscribed inside a circle. So can I draw an incircle here? Yes, I can. With E as a center, I can draw this incircle, and that gives me a visual proof of incenter making an incircle. And I also know how a circumcenter makes a circumcircle. Now last, let's see median. So I get the midpoint of one of the sides as H and I draw a median. You can see BH is a median which is drawn on to the side AC. So it is bisecting. As you can see, H is a midpoint of side AC, so it is bisecting the side AC. Similarly, I draw J is a midpoint of side BC, which means it bisects the side BC. And similarly, I draw I as a midpoint of side AB, which is bisecting this, and I join the vertex to the midpoint. What is this called as? Median. Okay, because median always goes from the vertex onto the opposite side and it bisects the opposite side. So I know, and the intersection point of the median is called as a centroid. So let's see this K which I get it here, intersection point of the green. Okay, green is our median. So that is nothing but a centroid. So I have all the three centers which are in front of me. I have a circumcenter, I have an incenter, as well as I have a centroid which are straight here in front of me. So D is my circumcenter, E is my incenter, and the K which I see here is a centroid. Now let's see how does this three centers change when we make different triangles. So first I'm trying to make a triangle which is an equilateral triangle. In an equilateral triangle, all the centers are same, hence proved. We can see it here. If I go ahead to make an equilateral triangle, all this three center will come at one point. Okay, so we visually prove that in an equilateral triangle, all the centers are one and the same. So your centroid is equals to circumcenter is equals to incenter. What if I make a right angle triangle? Let's try and see what are the properties associated with the centers of right angle triangle. Can I prove it here visually? So let's see, I make a right angle triangle. So one of the angle is 90 degree, quite visible to us. Side opposite to that is an hypotenuse. Midpoint of the hypotenuse is my circumcenter. So the circumcenter comes on the midpoint of the hypotenuse, something that we have studied in a right angle triangle, which says that circumradius is equal to the half of the hypotenuse. Now we know why. Because your circumcenter comes and lies on the midpoint of the hypotenuse. That is why your circumradius of a right angle triangle becomes half of the hypotenuse. So R is equals to R. And that is how you can draw a circle in a right angle triangle. So this is again a visual proof of the property which we already knew related to a right angle triangle, that the circumradius is always half of the hypotenuse. Now we know what is the reason. Last, the orthocenter is always the intersection point of perpendicular. So in a right angle triangle, you can see the orthocenter will be at the vertex, because you can see two perpendicular comes from two sides, and I can take one perpendicular from the hypotenuse. So the orthocenter will be at the vertex. Okay, so this also proves the property that we know about a right angle triangle. So if we just keep on playing with this triangle, the circumcenter, median, and the incenter will keep on changing. If you can see, this is just keep on changing, and if I again make it equilateral, what will happen? They will coincide and will come at one point. So we can visually prove everything that we have learned with respect to the centers. In an equilateral, all will be at one point. Yes, we proved it here. So this gives us a visual proof related to the different centers of a triangle.